morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are continuing our discussion of quadratic functions. We should finish up with this video. Couldn't get it right by the Climax Blues Band, but we could get it right, boys and girls. Let's get to it, shall we? We'll check in with them at the end. All right, so now we are going to consider the quadratic y equals 2x squared plus 6x minus 3, and we need to state the axis of symmetry. Recall that the axis of symmetry can be found using the formula x equals negative b over 2a, and we talked about that last time. This is my a, this is my b, and this is my c of the form ax squared plus bx plus c. So this is going to be negative, and b is 6, a is 2, so that's 2 times 2 is 4, negative 6/4, which is negative 3/2. So that's part A. All right. Part B, find the coordinates of the vertex. Okay. So the coordinates of the vertex, let's see. We have the x coordinate because the vertex lies on the axis of symmetry. So the x coordinate is negative 3/2. Okay. So in order to find the y-coordinate, all we do is replace x with negative 3/2 in the equation for the quadratic. So that's 2 times negative 3/2 squared plus 6 times negative 3/2 minus 3. And I will tell you, as not to waste time, that that is equal to negative 15/2 or negative 7.5. So the coordinates of the vertex are negative 15/2. Okay. Find the axes intercepts. To find the y-intercept, I'm going to let x equal 0. So y is going to be equal to 2 times 0 squared plus 6 times 0. We really shouldn't have to write this out. So this is going to be negative 3. And then the x-intercepts, I let y equal 0 to 2x squared plus 6x minus 3. So 0 is equal to, let's see, that's not going to be factorable, is it? So I'm going to use technology. And in doing so, I can either graph it or do the algebraic portion on my graphing display calculator. So I'm going to go ahead. We know how to do it graphically, so I'm going to go ahead and just do some algebra here. I'm going to do polynomial tools, and I want to find the roots. It's of degree 2 because it's a quadratic, and I click OK. And then if you look, it's my A is, let's see, 2. And b is 6, and c is negative 3. So 2, 6, negative 3 go here. We click OK. And we hit it, it punches it in for us. And there we go. There are our x-intercepts. So I am going to take a picture of that. Let me go back here so we have them. Boom, chugga-lugga-lugga, bang. And I'll bring them down here. Okay, so those are my x-intercepts. I should get rid of that 0 equals. So x is approximately equal to negative 3.44 and 0.436, rounding to 3 sig figs as always. Then we are asked to sketch it with all this information. I'm going to do a quick sketch. The vertex is negative 3/2, which is negative 1.5, negative 7.5, negative 15/2. 1, 2, 3, 4, 5, 6, 7.5. So that's right there. And I'm totally not in pen mode. 1.5, 1, 2, 3, 4, 5, 6, 7.5. So about there. The y-intercept is negative 3, 1, 2, 3. The x-intercepts are about 0.436, and negative 3.4, that's about negative 3.5, about there. And I got a nice little sketch right there. Okay. We could have also used the quadratic formula here to find the x-intercepts, but then we would add square roots and we wouldn't have a good idea of where it is, where the intercepts were. We can also sketch the graphs by completing the square, and that's going to put us in vertex form. Okay. Let's see. Vertex form is right here. Y equals a times x minus h squared plus k, where hk is the vertex. So sometimes it helps to do this. Here we go. So we're going to complete the square here. Y equals x squared plus 4x and then plus 3. Completing the square, I take half of the coefficient of the x term, and that's equal to 2, and then I square it, which is equal to 4. So adding 4 here, and you should be able to really look at that and figure out what it is you have to add to make this a perfect trinomial square. And then to compensate for adding 4, I also need to subtract 4. This becomes x plus 2, the quantity squared, 3 minus 4 is 1. Now look, this is x minus h is the form, so that means that it's the actual vertex is going to be the opposite sign of what's in here. So this becomes negative 2, and k is negative 1 right here. So those are the coordinates of the vertex. So at negative 2, 1, 2, negative 1, we can sketch it. We can quickly get the y-intercept here, and that's really all we need to sketch the graph. When x is 0, the y-intercept is 3, 1, 2, 3, right? And we know we have an axis of symmetry through the vertex. I should label that because it said to state the coordinates of the vertex. And if I have any point on one side of the axis of symmetry, I have a mirror image on the other side, and then I can do a quick sketch. So you can see where completing the square can be very powerful and get it in vertex form, because you can quickly get the coordinates of the vertex right there and there. So let's do this. Sometimes we're going to have a coefficient here, right? So we have to figure that out. So let's see. We have y equals 3x squared minus 4x plus 1. And so I'm going to complete the square there. Now, we used to be able to divide by 3 to solve, but the equivalent of that is factoring it out. And we can't divide by 3 because it's equal to y. It's not equal to 0 or something else. So if I factor out a 3 here, I'm left with x squared minus 4/3 x, because 3 times 4/3, the 3's cancel and leaves me with the 4, and of course the negative is here, and then plus 1/3, because 3 times 1/3 is 1. So now I complete the square and I get 3 times x squared minus 4/3 x, and so then I have to take half of negative 4/3. Let's go fraction, people, don't be afraid. That's equal to negative 4/6, which is equal to negative 2/3. That's important because we're going to use that. Then we square it and we get 4/9. So I'm going to add 4/9. I already have this 1/3, right? And so I have to, let's see, I also have to subtract 4/9 to compensate. Okay, so this becomes 3 times x, and this is what goes here, minus 2/3, because it's half of this squared gives you that. So that's minus 2/3 squared. Okay, now you have to be careful here because this is 3 times all of this, and then 1/3 minus 4/9, that's 3/9. 1/3 is equal to 3/9. 3/9 minus 4/9 is minus 1/9. Okay, so I have that going for me. And so I distribute this through and I get 3 times x minus 2/3, the quantity squared, and then 3 times negative 1/9, really important, that gives me negative 1/3. Okay, So now I know that my vertex is 2/3, remember the opposite sign, and negative 1/3. And so I look up here and I know that the y-intercept is 1 right here, because if x is 0, I get y equal to 1. Get my nice stamper, bam! And let's graph that puppy. Okay, so 2/3 about here, negative 1/3 about here, y-intercept of 1. So let's see, that's 2/3 away. So about here, 2/3 away from the axis of symmetry, which is that x equals 2/3, right? So right down here. That's how I got my mirror point, and we can do a quick sketch. Almost done. We've talked about this in class, the discriminant. When the discriminant is less than 0, you know your parabola does not touch or cut the x-axis. When it's equal to 0, it touches it, and when it's greater than 0, it intersects it in 2 distinct places. And I think that's what these are going to say. Let's move these. Yep, there we go. We just said that. Let's see what this is. Oh, and then this is, I always like to point out, this is in your formula booklet. So if we can use a discriminant to determine the relationship between the graph of each function and the x-axis. Okay, so this is just asking about the graph. So delta is equal to b squared minus 4ac. Remember, delta represents the discriminant. So this is equal to 9 minus 4 times 1 times 4. So that's 9 minus 16, which is negative 7. So the relationship between the graph and the x-axis is no intersection. No intersection. So that's all they're looking for there. Here, delta is equal to b squared, 25, minus 4 times negative 2 times positive 1. That becomes 25. Let's see, plus 8, which is 32. Okay, so that means that it intersects or cuts graph in 2 places. Also, we know this is a sad parabola because of the negative coefficient of the squared term, so it's going to open down and this one's going to open up. Okay, I certainly hope you enjoyed that as much as I did. We will see you next time. Let's check back in with the Climax Blues Band to cut us out. They couldn't get it right, but you can now get it right. And I am out!